Hello students, so in this lecture we will be discussing about pixel. Now this pixel which is the short form of pictured element. It is considered to be the smallest unit of a digital image. That means we have a digital image like this, which can be an image in your mobile phone or an image in your laptop, whatever. You can divide it into different units, and the smallest unit is known as the pixel. This is the very basic definition of a pixel. However, the definition of a pixel changes and with different contexts. So it is also a context sensitive term. For example, if we are talking about uh, the smallest element in a dot matrix display device, it is also called a pixel. It is also sometimes called a PL, or instead of pixel, we call it as a PL. It is the smallest element in a cathode ray tube screen, the fluorescent screen on which electrons hit, and there is emission of light. So you can also consider it to be the smallest unit of a cathode ray tube screen. Pixels are now the property that makes a certain area to be called as pixel, and is it can be manipulated by software. The area can be a dot, or it can be having a geometrical shape like a square. Now, the intensity of each and every, by manipulation, we mean that intensity of each pixel can be changed by using a software. For example, if we have an image like this, which can be divided into different pixels, each pixel, the software shall have the ability to change the intensity of each and every pixel. It also can be used in providing or detecting color, which is mainly red, green, and blue initially, and can be cyan, magenta, yellow, and black even. In the case of a camera sensor, pixels are the photosites, similar to the cathode ray tube. Sometimes a sensor and a cell is called a sensor, which is a single element in array of sensors. In the case of MRI, a pixel can be considered to be a set of component intensities of a spatial position. Take any spatial position, like here, you can take maybe if you take any position in the MRI, say this one. So this is actually component intensities that make up the spatial position. They are called pixels in an MRI image. Pixels are sometimes related to DPI, that is dots per inch, although they are totally two different entities. Dots per inch, a high number of pixel gives a high resolution. However, a high number of dots per inch will also give a higher resolution, but dots per inch or DPI is usually used in the context of printed material. That means, let's say, an inkjet printer, if it produces, which has a high DPI, will produce a good quality image. Now, the mobile phones that we all have, the camera, you might have seen that the camera has been technically said as having a megapixel camera. So megapixel means in a particular area that is there are 10 to the power 6 number of pixels, and as the number of pixels go up, the surface density of the pixels increase, the resolution of the image will also increase. In terms of astronomy, that is, when we are using a telescope, the angular distance between two objects, they fall apart, 1 pixel apart in the detector is called a pixel scale. So we can define a pixel scale as p by f, which is pixel spacing divided by the focal length of the lens that we are using. So, how to quantify how much pixel will give what kind of resolution? So, for that, another quantity called BPP, bits per pixel, is present. So, it gives the number of colors the each pixel can show or can detect. So more is the number of colors a pixel can detect or show, the more is its resolution, and it depends upon this quantity bits per pixel. So if it is in 1 bpp bits per pixel, it means 2 to the power 1. So basically you can only have the black and white image. If it is 2, then it becomes number of pixels, number of colors that it can show is 4, and the list goes on. Now if it is a 16 bpp, that is 2 to the power 16 different colors can be हाँ नीरज जी बोलिए. हाँ हाँ ठीक है ठीक है, ओके. Okay, so if the number of bits per second increases, the color quality increases. When it reaches 16, it becomes high color. It is called high color. That means 2 to the power 16 different types of color can be detected in that pixel. And when the number goes to 24, it is called a true color. So that is actually the maximum limit a pixel can resolve or can show image having colors. Now there are some pixels which cannot recognize the different colors. For that, the pixel which is in the form of a grid is divided into subdivision, is subdivided. Like in this case, the pixel grid has been divided into 3 different colors: red, blue, and green. So each region we can now detect the red, blue, and green colors. So these are called subpixels. Now, pixel is used in estimating how good a sensor is, or how the sensing efficiency of a sensor can be determined by pixel, where pixel is used as units. Like suppose you have a geometrical area, so we can see that it is this pixel width and this pixel long. Now, the detection of light that takes place is through a circuit, through a device called charged coupled device, where photons are used to form electrical signals, and we have a conveyor belt consisting of pixels, as can be seen here. These are the pixels. And these are the photons falling on the device, and the conveyor belt moves to change the location of the pixel. The intensity of light, mathematically, if it can be represented by the unit candela or lumen or lux. These are the 3 units: candela, lumen, and lux. Now, intensity of light, luminous intensity, is the measure of the amount of light emitted from a source in the given direction. And so basically, one candela, as you can see here, is equal to 1 lumen per sterdian, that is a solid angle. And the 1 lumen is equal to then 1 candela sterdian, and 1 lux is equal to 1 lumen per meter square. That is 1 lux. Apart from that, there are other units defining the luminous intensity, like Hübner-Kenz HK, which is 0.903 of candela. Then we have candle power, which is 0.981 candela. So it's close to 1 candela. And we have NIT, NF. So net, that is 1 net, is equal to 1 candela by pi. So it is 0.318 candela. So that's the different units by which we can determine the light intensity numerically.